All right, let's check how you did. Did you get 7x squared divided by 2 minus 3 natural log of x plus 5e to the x over 3 divided by 1/3, which, if you simplified that, plus c. So some other standard ones, sine and cos. If the derivative of cos is negative sine, then the integral of sine is negative cos. Okay? If the derivative of sine is cos, the integral of cos is sine. And if you had a value inside that you were multiplying, if you were doing the derivative, you would have the chain rule and have to multiply. So if you're doing the integral, you would have to divide to counteract that chain rule.
Could you just think of it like if it's an area under the curve, you think of the sine graph, the area under would be negative, so you just go negative cos.
The area under the sine graph is negative.
Would it be? Actually, no.
No.
It turns positive. Right?
Sometimes it's positive, sometimes it's negative.
How would you like graphically explain that?
Again, I always think back to my derivatives and my slopes. And I think, okay, if I have my sine graph and I draw my beginning derivative, it's got a positive slope, which matches up with cos being positive. And if I draw my derivative off of cos, it goes to the negative right away, which can only match up if sine goes negative right away. So it gives a negative sine graph. So sine of 5x, if we're working with sine of 5x, the integral will be negative cos of 5x divided by 5 plus c.
Wait, is that the notation for integral?
Sometimes they use a capital letter when they're going from one function to another, but it's not.
An integral?
So I could write this. I introduced that, but you could write, this would be better. Okay, so the integral of, since the derivative of sine is cos, the integral of cos does not change sine. And this dividing by 1/3 is the same as multiplying by 3.
Yes, sir, it is.
The derivative of sine is cos, so the integral of cos doesn't change sine.
No, I'm saying derivative. I like to think it's an antiderivative. I'd like to think the opposite. So it's like the derivative of cos is a negative sign, and the integral of cos would just be sine.
Okay. This is where you're going to really have to think, because learning something new causes your brain to have to really think about the signs. The integral of cos is sine.
That's a good. I got it.
You got it?
That's it.
It doesn't matter how you think about it, as long as it's theoretically.
Do the derivative, do the opposite.
Awesome.
Okay. Our next stage is looking at derivatives of the form ax plus b, so we can do integrals of the form ax plus b. So what happens if you were going to find f prime x here? 7, 5x plus 3 to the 6 times by 5. And so if you had ax plus b cubed, the derivative would be 3ax plus b squared times a. And just doing this set, what happens with natural log? It becomes 1 over 4x plus 7, but then you have a chain rule, times by 4. And so the natural log of ax plus b would become 1 over ax plus b times a. Okay? And what we're trying to do is see if we can find a pattern of something that happens when you have these ax plus b form. Again, here, f prime of x will be e to the 10x minus 5 times 10. And here, it would be e to the ax plus b times a.
Wait, if he was worried about his property flooding, why would he be shoveling snow right onto the wood, shoveling it onto a giant pile of property?
Well behind.
So the key thing that we need to notice is that whenever we do a derivative, when you have ax plus b, you always have a chain rule. And with that chain rule, you always have to do the derivative of the ax plus b, which means you're always multiplying by a in the end. So if you wanted to integrate something like this and work backwards, you're going to need to have to compensate for the fact that you have that multiplying by a. So what does that do for us, or how does that work? Well, if we had our regular product rule, in order to compensate for that, we add the fact that we're going to have to also divide by a. Because that'll compensate for the fact that when you do the chain rule, you would multiply by a.
Yeah. You add it back to the top and divide by what you added.
Yeah.
Take the integral of the natural log. What do you get?
If you take the integral of a natural log, you get a complicated expression. I think you get natural log, x natural log of x minus x or something like that. Can't remember off the top of my head. I have to refigure it out. Okay, so here we want to find the indefinite integral, and I'm going to change the cube root to a 1/3. What would this be equal to? Well, the product rule says add 1 to the exponent and divide by your new exponent. And the ax plus b tells us if you did a chain rule, you would have to multiply by 5 afterwards. So to undo that, we're going to have to divide by 5 as well. Simplifying this complex fraction, we divide by 20 over 3. That's the same as multiplying by the reciprocal. So we would get 3, 5x minus 4 to the 4/3, all divided by 20. Plus c. Yes? That's fine. That's fine.
Could you just
So
make
try.
8 a
Yes, that would be the first thing I would do. And what would you get? Add 1 to the exponent, divide by your new exponent. You're going to also have to divide by 9 because of the x plus b. So you get a negative 63 on the bottom. And this same idea is true of any kind of integral that we can do already. So if we had natural log of ax plus b, you would have to, or if you have 1 over ax plus b, you'd have to divide by a there for the natural log. If you have an e to the ax plus b, you'd have to divide by a. So in a sense, this is undoing a chain rule, but a very simple chain rule, because the chain rule ends up just being a constant. And we're leading up to more complicated undoing of chain rules, which we'll get to next. Two examples here.
Teach us.
Oh, yeah, I think you should try them on your own.
Oh, teach us.
Yeah, I know.
All right, so recognizing the x is on the bottom, it's an x to the 1, so there's a natural log. 15 natural log of 3x minus 5. And then also recognizing that if you had done the derivative, you'd multiply by 3. So we have to divide by 3 to compensate. Second one.
Can I see that?
You want to see that again?
That'd be 5 in natural log.
Yes, it would be 5. 15 divided by 3 is 5. So normally the integral of e to the x stays the same. But if you were doing the derivative of this, you would have a chain rule where you'd multiply by negative 3. So you divide by negative 3 to compensate. Same thing happens with sine and cos. Have you done the next two?
No.
No. Oh. So here, the integral of sine would be negative cos, because the derivative of cos is negative sine, so the integral of sine is negative cos. And then there would be a chain rule, so you divide by 6 plus c.
Which is really the same as negative 1/2.
It's the same as a negative 1/2. You could reduce it if you'd like. And for the last one, since the derivative of sine is cos, in order to get a negative cos, we would have to have a negative sine. We have to divide by 9 to compensate for the chain rule, plus c. Especially with sine and cos, after you're done integrating, take the derivative to check to see if you got the right answer.
Derivative of cos is negative sine. So the integral of cos is sine. Yes, the integral of negative cos is just negative sine.
Right? The negatives can cause your mind to